Okay, well, building codes are interesting things. They've been around for thousands of years, but when it comes to Australia, it really started off in the start of the 20th century, 1900s, and prior to that, we were pretty much just copying what was happening in the UK. So, London City Council was really the rule setter, and interestingly, that for all the English colonies around the world, US, Canada, New Zealand, etc., and that's also where their code starts. So we all kind of like have a same starting point, is that we're influenced by the Great Fire of London, which had stuff put in there basically around stone and masonry walls, and that goes back even back in the Roman times. So the Roman emperor fiddling while Rome burned type stuff. So Nero, and some of those rules and regulations have really been stuck in train and our thing going through from UK through to Australia. We had back in the 1850s, there was building regulations and stuff which are pretty much the same around Australia, and they're very limiting. They were planning and building regulations. But really, it started the 20th century is when then they started to go in earnest. And local jurisdictions, local areas started picking up, and that's when we started getting differences. So up to that point in time, most things were similar around the world. So our colleagues in Canada and US and New Zealand pretty much had the same rules as UK. And then all of a sudden we got committees started in those things, and that's when we diverged. But a lot of the stuff is based the same. So it's interesting to see where our history is, and also explains why some of the things are like some regs there really reflect how we used to build back in the start of the 20th century. They're still contained in the regulations that we work today, and we just don't realise that. But we got to maintain existing rules unless we got some reason to change them. And we see some of those things sneak through into current thing, and wonder where they come from. And it's they could be 100 years old.
Yeah, and you mentioned that the Great Fire of London. So that was obviously a huge event that happened, and then after that, the building codes were I guess extended and built more stringently and affected combustible or timber construction at the time.
Precisely. I think you'd see that every time there's a disaster somewhere, as we get some reflex and regulation, and that's what we see. So we see it in the day, like we have, the black weekdays of bushfires. There's been a few of them, so there's almost every day of the week now. They've caused some regulatory change and etc. Up to now, we've got the composite aluminium cladding is causing regulation change after disaster. It goes back to Grenfell in the UK. So all these sort of things cause change. Sometimes they overdo it, they overstep the mark, they go too far. Other times, they're on the money, and that's what we got to deal with. Is that it's not there's normally a step change caused by some disaster occurring. But if we go back in history, people think building heights are limited on fire and things like that. And they weren't. They were more about access for sunlight into windows and widths of roads to get for emergency services and things like that. So there's not necessarily why we have some stuff in our regulations that is obvious.
So the NCC, there's a lot of authors over a long period of time who've contributed. Can you give us a bit of an overview of the NCC and how it works and how is it structured if someone was trying to make their way through it?
Yeah, it's an interesting beast, and we all struggle with it. I'm not a code expert or anything like that. I'm a structural engineer in background, but I saw the need to understand the regulations to be able to utilise them. So in recent times, I spend most of my time talking about compliance, and it's because we're in a particularly necessary that we need to demonstrate compliance, and we're getting more and more of that. But the NCC itself, look, it started from we had state-based regulations, and each state had their own rules, which again were based loosely on those in the UK. And then, back in the 90s, someone decided that we needed to be more national because we don't want different rules in different states because it just had an expense, and that's where that came from, the NCC. And it's a document which it's a difficult document to read. It used to be harder. It used to have parts to it which were all spread through, and you have to when back in the day before the we had soft versions of things, you used to have these multiple places where you stuck your finger in the book trying to go from one clause to another one just to make sure you cover it all. But these days they're getting better. It's putting things together where they logically sit, but they still have the occasional flashback to the old days where they put something in there. For example, the fire resistance for apartment buildings above 4 stories contained in the sprinkler area of the NCC. And then they take precedent over the requirements in the Section C, which is where the fire and stuff normally is. So you got a bit of strange there. Unless you knew that, you wouldn't know that there's important information contained elsewhere in the. You would go to the Section C, read that on fire, and be oblivious that there's another section over in the sprinkler area. So it is important to have an understanding of all these things, because you get surprised, and I'm no expert in all this, but there's always something that surprises me in the NCC. So don't think that you know everything from it. It's always something that springs up or you've forgotten, and that's what some of my role is just to remind people that has been around, with this concessions, and it's particularly in the timber industry is that, and particularly in the timber building designs, we're using parts of the NCC that people don't often use. So they're familiar with the concrete and steel parts, which don't take you into concessions and other bits within the NCC, but we have them in there. And so a lot of the time people are venturing into new areas that they hadn't seen before. And I keep getting asked, when did this occur? Is it a recent thing? And I said, if you say 40 years ago was recent, then yes, but it's not. It's been there for a while, and they didn't realise it's been there. So I said, you could have been utilising this particular saving on your project 40 years ago. So it's nothing really new. And again, it gets back to what I'm saying before. It's a hangover from our previous history of where the regulations come. And you got to remember, back in the start of the 20th century, wood was a major part of building design. It was there. So some of those things are still found within the regulations today.
Absolutely. So in the NCC, it's obviously trying to achieve some intent. What are the performance requirements in the NCC, and what do they represent? And then what are some of the pathways to achieving these requirements?
Sure, good question. The performance requirement is what you have to achieve. That's what the goal, the objective of the NCC. So you have a number of ways of demonstrating that, and that's through a performance solution, which is engineers. I can't think, put an engineer design into that. And there's the other one is called deemed to satisfy, which is a cookbook approach, where you follow a set rules, a recipe, and you end up with meeting the performance requirements. But there's really a third way, and that's that most things are actually a mixture of deemed to satisfy and performance. It's quite often that you may just have a few parts of your design that varies from the cookbook, and you're only doing performance solutions over those bits. Think about it. We have ventilation and lights and windows and all that type of stuff. They pretty much stand. No one really changes them. But we might play with the fire stuff, because fire stuff is expensive. So it's a fairly large proportion of the cost of a building. So it's a logic that we play in those areas to improve our cost efficiency of the buildings. And that's where some of the drama occurs, and where all these concessions I was just mentioning before. The other thing to also understand the structure of the NCC is that there's not just one solution in there, and particularly in the fire area. I've found different FRLs from different solutions for different heights and buildings, and some of them, there could be like 5 or 6 solutions for a 2-story building in a residential building in the NCC. So just because you might think there's an obvious one, and for us, the fire protected timber is an obvious one, it may not be appropriate for low-level buildings, because there's other things which are more in tune to that design. So just be aware that there are lots of solutions out there, lots of ways of doing it. The rule, there's not just one rule or one cookbook. There's multiple cookbooks in it, and it's just a matter of picking the one that's most appropriate for your building design.
Yeah, absolutely. And I've fallen in the trap a few times in my work where I just assumed everything needs to be plasterboard protected, and then it might be a 3-story class 2 building, and then I think I gave you a call on us, and all of a sudden I was illuminated that you didn't need an FR. And we'll talk about types of construction and FRLs later, but it turns out that you could have a fully exposed structure. I mean, and getting that wrong, you're obviously putting huge costs on the project in terms of the amount of plasterboard that doesn't need to go in there necessarily, and then also having as much exposed timber in there. So there's a lot of different things that to really learn from the NCC, and yeah, a lot of us don't really pay that much attention to it, it seems, don't you think?
Yeah, so probably, I'm probably a rule breaker at times, so I don't like to follow the rules, and we tend to want to break them occasionally. But do you think about it? It's logical to have differences. Like a single-story building doesn't need the same fire protection as a 100-story building. And also if the occupancy changes, if we have someone who can't get around, a young child or someone in healthcare, they have different requirements. So the NCC captures all this, and it has appropriate rules to match that. So there's not one solution that's going to cover all building design. So for a low level building, and it does vary through these types of construction, you can get away with using exposed timber. And there's also lots of applications where you have no fire requirements within the NCC. It could be just a partition wall, which you could use exposed mass timber or exposed timber in. It's not necessarily. We mainly focus on the fire-rated ones and load-bearing ones because they're fairly important. But there's other walls and things that you can use. So sometimes when I'm talking to people with designs, we can simply say you want to expose mass timber wall. We'll just put it in a wall that divides a lounge room in a bedroom or something, and that could give you your intent, or etc. It's really when we get to the bounding walls and load-bearing walls that we start getting a lot more rules being applied.
Yeah, do you recommend having a building code consultant on a project? Because we were talking before, you got the performance requirements, and you can go a DTS solution where you don't need a fire engineer, and then a performance solution where you need the fire engineer. But I mean, that step before both of those solutions, is that where a building code consultant might be sitting?
Yes, I agree 100%. It's good to get them involved in an early point in time, because you want to find, with your design, where you comply and where you don't. And that makes the decision where, if you go and chase a performance solution, a bit more easy to do it. Because if it's a lot to change, then it's going to involve a lot of performance solution. And you can just imagine the stakeholders, the authorities, are going to be more careful about whether there's lots of departures from being satisfied compared to something which is only a minor departure. So finding out where where your building sits is exactly what you need to do first. And so a building consultant does that for you. I tend not to involve the professional engineers at that level of time. Don't get your structural engineer or your fire engineer involved, because they're going to send a certain direction which favors their solution. Get them just to the client and probably the architect to do a review of what it doesn't meet in regulations, and the decision can be made. Look, a lot of buildings over 3 or 4 stories are performance solution. There's a part in them, so it's likely to be. And the other aspect to all of this is, if you do a performance solution, particularly if it's fire-based, you got to look at a whole lot of it, because you just can't have one thing that changes and just do a performance solution about that. It needs to have a look at the entire compartment, and because there are elements impact on other elements. So if you find a better solution, one thing, it may have an impact on something else you haven't even considered. So it's good to make sure the design is holistic in considering everything. So but yes, it's just be wary about seeking the best advice, and so you go fully armed in to any conversations later on.
Yeah, 100%. And so one big component of exposed timber, or any timber product, really is the FRL, so the fire resistance limit. How do we determine this, and what actually is the FRL? What is it actually trying to communicate with that prescription?
Good question. And look, the FRL is fairly important. That's the fire resistance level, and that's really the how we compare products in the system. So it's a level of performance we require for really compartment. And the idea is that we're trying to retain the fire within the compartment where it started, so that the occupants can get out of the building and the emergency services can safely get in to do something with it. So you're trying to contain within the boundary, and obviously we had different documentations where we need different fuel loads, which means they're going to have more resistive barriers, and or they could be the occupants themselves need more time to get out of the building, so they need more barriers to last longer to make sure it doesn't impede their exit. So there's all these things that are going on in the thinking of it, and so the FRLs themselves are really just a measure of the fire resistance and how well it's going to perform, and it's based on something which was developed 100 years ago. You can just imagine 100 years ago, everyone was saying their structure was fireproof or their system was fireproof, but you had no way ability to measure. So someone could have something which wasn't fireproof, another one who was over the top. So they came up with a means of demonstrating it. So they made up an imaginary fire, which is an endless fire, and basically had the time periods for the element to resist structure, integrity, and insulation, so the heat or the flames don't go through the barriers, or it doesn't collapse. And these are pretty much stayed around for 100 years, and look, they've been working really well. It's also a means to demonstrate, or not demonstrate, but to commercially trade. What you'll find that a fire engineer may come up with a particular fire. So this standard fire, which describes the fire resistance level, is not a fire which occurs in buildings. So the fire engineer may design something which is the worst fire case in that building. Doesn't resemble or match the fire that we designed as fire resistance level. It doesn't matter. It's basically the fire engineer can determine what the equivalence is, whatever means they want, of their fire, their worst case fire with their FRLs, because you can't say to a builder, look, I want you to have a wall which is able to resist a temperature of this and for this period of time, which they got, means they got no way of comparing costs and equivalence in building design. So we fall back to fire resistance level as the currency of trade in fire resistance. So how do you determine that? The NCC is quite clear about that, and this is one of the things that's cleaned up over the years. These things are a lot easier now to find within the NCC. So it has a one sentence clause in the requirement NCC says to go to Schedule 5 within the back of the Volume 1 or Volume 2, and it has a process of how to determine your fire resistance level. And there's 6 ways of determining it, and not all appropriate for all materials. So you could start with as a table within the NCC that describes how you can achieve fire resistance, and that's more related around concrete and steel protective systems. Doesn't contain any timber one. But the most commonly used one is a fire resistance test. So a test in a furnace, standardised one, which is pretty much the same around the world, and that's the predominant one. So a prototype testing of your system, and then the other ways are really about parts of it. I said six ways. They're about your ability to change those, because we can't go and test every wall and beam and column configuration for a building, because it'll cost more than the building. So we do some prototyping or systems that represent what we're trying to do, and we do that, and then we extrapolate those or interpolate those to other systems. Like for us in timber, we have different stress grades and lengths of walls or whatever. So we can't do a fire test for every grade of timber out there, or every thickness of CLT wall or whatever. We need to have some way of shortcutting that, and that's where the expert opinion comes in, and you can have a person who's experienced that can vary a test report, or someone who can do calculations. In addition to that, we have a reference standards. So most materials have a reference standards. Timber industry has one. It's 1720 Part 4, and it's working on notional charring rate. So it makes up imaginary charring rate, and from that you can determine your structural resistance and also your insulation. It doesn't do integrity. You have to do integrity by tests. So you're getting part way there, and it's quite straightforward in the calculation method. But you need a material which is well known. So it has in front of the 1720 standard, we have products that were well known, so it defines what they are and includes adhesives. So if something new which is not known by that, then expect that that need to go back to fire resistant testing, back to your furnace and test it, because it's something which isn't common. Remember what standards are. It's a standards process. There is a strange one at the end of it. There's one that says fire protected timber, and I'm not quite sure what the fire protected timber stuff, but it's a bit of a, it talks about fire protected timber, and you think that's the place that you can determine from it within Schedule 5. In reality, it's going back to the other five ways above it. And so it's not actually a method, it's just reminding you that fire protected timber has a certain building height and requirements for it to work in. So it's a lot easier now that we have it all contained in Schedule 5 in the NCC. So get used to it, get familiarise with it, and you're really looking for test reports which comply with the Schedule 5. And that's when you know you've got a compliant system. And for us in the timber industry, it's either going to be a furnace test to 1530 Part 4, or a calculation through to 1720 Part 4 standard. And that's how you determine your fire resistance levels.
Yep. So assuming that you've got tests or products, some products might be a fire test, for some products it might be a standard like AS 1720 Part 4. Do you think that, with the right detailing and design, that the need for testing is just perhaps not there? Because I know this is something that frightens developers a bit of an unknown, an uncertainty that might hurt program and be all of a sudden a cost that pops up. So how can they sort of avoid that risk entirely?
Yeah, look, it's using standardized systems. If they've got something which is unique, then yeah, there's a fair call to do a fire test if it's not been used before or seen before. But most things have been done before. One that springs to mind is connectors. How many times I've seen connector tests done? It's just ridiculously overdone. And the base system, 1720 Part 4, which is the char calculation method, has a system in there, and it basically says that you encapsulate it with timber, and it works. What normally happens is you might get a gap or something, so you need to treat the gap. The timber bit works. It's just then you cover the metal connector, which is normally there. And timber is a great insulator and a great fire resistant, so it works well. It's just you may have some variations, and WoodSolutions has done some work, available work to solve some of these problems. So have a look around. Most things have been done before, and it doesn't matter if the load is different. It's basically the principles are the same. There's you're just looking for that protection for it. There's no real rocket science. We know that because you look at the next version of the Eurocode on fire, it actually has calculation methods for connectors, so they're comfortable enough to put those into a standard. Which, remembering the idea of a standard, that is standardizing things, it means you can it only occurs when there's comfort with those levels. But we're always looking at one thing with mass timber, particularly there are new areas, and we're always challenging the boundary of it. If something new comes up, yes, it just needs a test to support it. So for most parts, if you stay within the known, then it doesn't need anything. If you suddenly get adventurous, then obviously you need the evidence to support that it has the fire resistance. But if it doesn't depart too far away from the principles, then no, it doesn't really need it.
Before, toward the beginning of the podcast, you mentioned Grenfell, and there's been other fires like La Crosse where you had a combustible cladding, which was what was it? A aluminium something
composite? Yep.
Aluminium composite.
Yep.
So building surveyors were pretty nervous about that. I mean, and do you think that's like flowed through some of those nerves towards timber at all? And do you think, is there any reason for building surveyors to be nervous in specifying that in timber construction who are new to it? Well,
I think it gets back to what's new. If something's new, then they're nervous because they don't know the risk behind it, and they need the education. And I often call it a journey. So if you just throw something at a certifier and say, "Look, approve this," and they're going, "Well, I've got no idea how it performs." That designer may have had years of experience and done the work. So the certifiers in the same boat. They're just as they're new to it, and they're unsure. So they're going to be risk averse and looking for things. And particularly if you don't support it with the evidence, it's trickier for them. So you got to bring them along the journey. I'm always a fan of involving the certifier in the early day, because they're just the same as you and me, interested in knowing what the background to all this is. And when you do take a certifier, which I have done, to a fire test, and I just see the level of conservatism in all of this, I go, well, it's not a worry. I'm comfortable with it. It's it's performing similar to concrete and steel, and because they're having the same levels of thrown at them. So it's a matter of remembering your certifier is maybe new to all this and needs to be educated just as equally as you have, and they're looking for the appropriate evidence that they can rely on. And is when you get gaps in that, as it may have occurred with the aluminium cladding situation, then that's when things fall apart. So it's use people in companies that have done the work and got the evidence to support their products. It's and if you don't have that evidence, then expect to get a test done, because it's the certifier needs that comfort that the system is going to perform. They can't take a punt, because it's a risk they've got to take, and insurance won't cover it.
That's phenomenal. It's been great chatting to you on this topic today, Andrew. What excites you about the future of timber construction looking forward?
Well, I think it's because there's so much new out there. I look at mass timber. Like, we built a first mass timber building in Australia just 10 years ago, not even 10 years ago. So that was completed in December 2012. We're now seeing so many of them, and that design, which was designed back in 2012, you don't really see anymore. So we've moved away from that, and we're just getting new systems coming up all the time. We're finding improvements, and always finding better ways of doing things, which adds to just a previous conversation, which means they also need all their homework done and certification put in place. And sometimes people want to get onto a project before that's the case. But I'm seeing that we're getting understanding these systems more, and we know where they work more. So we're utilising the features, and we're seeing hybrid buildings. So where materials are used where they're most appropriate. And a fundamental thing within the timber industry is that we wanted timber to be considered as an equal material compared to steel and concrete. We don't expect the building to be entirely made from timber or etc. or concrete or steel. So it's actually the best product to utilise in the best area that we're trying to get to. And we're just seeing some of that with these hybrid buildings. So I'm excited about that. And they're pushing the envelope. We have people who are building buildings. When Forte was built in 2012. Someone said to me in, say, 2005 that we're a 10-story building in Melbourne made out of wood. I would have rolled around the floor laughing. And if someone in 2012 said we're talking about a 40-story building with has components of timber in it and a hybrid one in 2022, I'll be rolling around the floor laughing again. So I'm not. I've given up rolling around the floor, and just looking at now that there's nothing going to surprise me now. And always give an example is that nature's still beating us. So nature grows trees taller than we can build at the moment. So we haven't caught up to nature yet. So we still got a lot to learn before we get to the heights that nature's already achieved. So it's an interesting time, and it's a good time to get involved in timber. And I recommend anybody too, because it's that aside, it's got a great climate argument as well. So that's what my future is looking for is change and dealing with the change.
Yeah, well, it's happening at a very fast rate, of course. If people want to find out more about yourself, Andrew, and what you do, or is there anywhere people listening right now, where should they go to learn more?
Well, I think the important thing is that what we do in the timber associations nowadays is we don't necessarily have one association above another. We focus back to our campaign called WoodSolutions. So go to WoodSolutions is what I recommend as the first port of call, because it's going to answer most of your questions. When you get down to my level, you got a tricky question. Okay, so so I get the challenging ones and etc. So WoodSolutions will sort that out. So you got to some mechanisms you can do. Obviously, go to the website and they'll have great resource and material there, which probably will answer most of your questions. Obviously, there's as you get, if you got something really unique that's not been seen before, or it's etc., then the WoodSolutions network will point you in the right direction. And when one thing about wood, it's used for many applications. It's got many different things. So there's different people with different levels of experience that to use. So I don't think there's one person who's experienced over everything where timber can use. So it's a matter to use the resources through WoodSolutions to identify who's the best person to help you with that question.
Thanks so much for coming on the podcast, Andrew. That was phenomenal.